Recording. Welcome to Computer Science IGCSE, and we are going to start our paper number 2. The name of paper 2 is Algorithms, Programming, and Logic. And chapter number 7 name is Algorithms, Design, and Problem Solving. Right?
Yes.
Yes. So names are quite similar of paper 2 and chapter 7. Right? Okay. So the first topic of our chapter number 7 is the program development life cycle. What is the name? Tell me.
Program development lifecycle.
Basically, in junior classes, you guys learn about the life cycle of butterfly. Do you remember? In science, you learn the life cycle
Yeah.
of butterfly, life cycle of lizard, life cycle of a plant, isn't it?
Yes.
What you learn in that life cycles? What is the basic concept of it?
Like how they are made, how they adapt, and how they live.
Exactly, just like that in computers. And we have a programs, and in our programs we have a cycle, a life cycle. It means how we develop program, how the program look like, how the program designs, and how it looks, how it works. This thing is called program development life cycle. Is that okay?
Yes.
Okay. So in my slide, you can see the program development life cycle phases is the first phase is analysis. The second phase is design. The third phase to code the program. Fifth phase is testing. And there is one more phase in our programming. That is called maintenance. What it called? Maintenance. Yes, maintain. How to maintain the program. This is very important, but it is not included in our syllabus. So what we have analysis, we have design, we have coding, and we have testing. Is that okay?
Yes.
Starting with the first phase of our program or first stage is called analysis. What do you think? What is analysis? Let me tell you. While we are going to develop any software, any program, we need to collect some information. What? We need to collect some
information.
The information is about the program code, how the program looks, what are the things we need to develop our program, what are the inputs, how the output look like, what are the things we need in our program. These all things are called analysis. So while we are going to create any program, the most important step is analysis. So what do you think? What is analysis? Analysis means to collect information, right? To collect information about the program, to understand our program, right?
Yeah.
To understand our program, to understand the requirement of our program. Look, so these things comes together to make analysis, right? So in analysis, you understand that what will be the input, how to collect the input, what will be the output, how the program look like, what are the things you need, what are the things you don't need. These all things come under the word specification. What? Specification. That's what program specification or program requirement. Is that okay or not okay?
It's okay.
Specification, or you can say program requirement. I'm just writing REQ requirement, right? So after collecting of all these data, we are going to produce a report, and that report is called feasibility report. What it called? Feasibility report. So feasibility report tell you what things are needed, what things you need, required to make a program. Feasibility report, right? So these are some words we need to use in our analysis stage. So analysis means to collect the information.
Okay.
Right? Look, data collection and information. So it is very important to allocate time to this. Yes, this is the most time consuming phase of the program. Like you take a lot of time in analysis, right?
Yes.
Yes, okay. You can see this is a feasibility study while you're working on the ideas of the program, and then you are going to create a feasibility report, right?
Okay.
Now, in analysis stage, we are going to divide our program into a stage. That stage is called abstraction and decomposition. So in analysis, we have stage one, the analysis. Stage two is a requirement, as we discussed about the requirement and needs of the program. And the third stage right here is abstraction and decomposition. So this is a stage of analysis, right?
Yes.
Any idea about abstraction and decomposition? Let me tell you. The next stage of the analysis is to carry out abstraction and decomposition of the requirement. These are of the two key elements of computational thinking. A very good word used here. Whatever you are doing to create your program is called computational thinking. What? Like if I'm asking you to create a program, whatever you are going to search, think, is called computational thinking, right? So what is computational thinking?
Yeah.
The thinking we use to order to develop our program, to create our program, to find the analysis stage, designing stage, and coding stage, testing stage. These all are come under computational thinking. So while we're going to do analysis, there is a most important thing: abstraction and decomposition. So let me tell you what is abstraction. Abstraction is the process of selecting information in a problem and focusing only the important parts of the information. During abstraction, any detail that is irrelevant to the problem is ignored. Wow. What is that thing called? Let me teach you in a very, very easy way. Just give me a second. Let me show you something. Then you are able to understand. Okay, young man, can you see my screen?
Yes.
How many maps are there?
Many.
Not many. There are only two maps on my screen. A left-hand side map and a right-hand side map. Which map is easy to understand for you? Right-hand side or left-hand side?
Right.
Which one? This one?
Right.
Yes. Why right-hand side? Because
it has less stuff.
Yes, it is very easy to understand because there's no road, there is no trees, there is no green points, there are no city names further like you see on the left hand side. You can see this map is quite difficult to understand because there are so much, a kind of things inside of it. So I think so this is not a good idea. So we are going to delete the unnecessary things and make the map easier. And This is called abstraction. So abstraction means to delete all the unnecessary things from your program and make your program very simple. What is abstraction?
Basically, to delete all the like what we see over like repeated stuff
Yeah,
and unnecessary details and only keep the important stuff.
exactly. So we are not going to use the information which is not required because this is unnecessary, right? So abstraction keeps the key elements required for the solution to the problem and discards any unnecessary details. Simple. Is that okay?
Yes.
Next part of our analysis stage is a decomposition. What is decomposition? It is going to break down a complex problem into a smaller parts, which can be then subdivided into even smaller parts. Then can be solved easily. So what do you mean by decomposition? Look, decomposition is breaking down your problem into the simple steps. Look, I'm doing it. Look, this is called program decomposition.
Okay.
So further, you're going to break this problem into further smaller parts. Are you getting it? Look.
Yes.
So breaking down your problem again and again into the smaller parts, then again and again into further smaller parts, then again and again into the smaller parts is called what?
Decomposition.
So what is decomposition? Tell me again.
When we break the problem to smaller problems or smaller parts.
Exactly. So what do you think? Is it good way to understand our problem?
Yeah.
Yes, decomposition is a very good trick in order to understand the big problems, right? Big problems are going to be breaking down into the smaller steps. So the programmer becomes easier to understand your logics, right?
Yes.
Great. Okay, now I'm going to give you a writing task right now. First, what you have to do, you need to write down the stages, name, then you need to write down about analysis. Whatever I teach you, you need to make 3 points on analysis. Then you need to write down about abstraction and decomposition. Definitions, right?
Okay.
And then let me know. I'm waiting. If you need any guidance, if you need any slide to move on like that, let me know.
Yeah.
For understanding the first phase of analysis, now we are going to move to the second phase of our program development lifecycle. So what is the second phase is? Design. So in a design phase, you can see the program is being demonstrated with the help of a structure charts, flow charts, and pseudocodes, right? So basically, design phase is going to be used for the programmer to design the program. So the programmer should know how the program look like. So once he's going to develop the program code, designing the structure charts, designing the flow chart of the program, he comes to know how the program look like and how each task is performed. So design phase can be completed with the help of these things called structure charts, flow charts, and pseudocodes. Now, what are structure charts? Look, I have already drawn it for you. This is called a structure chart. Decomposition chart is also called a structure chart, right?
Yes.
Decomposition chart is also called structure,
Structure chart.
and it is also called top-down design. Yes, it is also called top-down design.
Top down.
Yes. Tell me the name again.
Top
Structure
down
chart,
design.
top-down design, right?
Yeah.
And one more name is left. Subroutines. What? Subroutines.
Subroutine.
So many names are there. There are many names of a structure diagram. Routines. Is that okay or not okay?
It's okay.
So design phase is the most powerful phase of your programming. So while you're going to develop the program, you have to concentrate on the design of the program. That is the most attractive thing. Like, it is just like the way you are looking, the way you are dressing up. Just like that in a program, in a programming, problem solving, the designing phase is important. Okay?
Yeah.
Okay, what is the next phase we have? We have coding and iterative testing. So the program or set of program is developed. Each module of the program is written using a suitable programming language. Now, after designing the program, after understanding the program, you are going to start writing, you are going to start coding by using a programming language. Either you are using C++, you are using Java, you are using Python, you are using any other language. You can use any language to code your program. That is called coding, right?
Yes.
So after coding your program, of course, you wanted to test your program. Like, is your program is running? Is your program is doing the task, whatever it is designed for? This thing is called iterative testing. It means you're going to check your program whether it is working according to the given code or not. So the iterative testing means the modular test. So you're going to check your program modules by modules. So if you wanted to amendment, so you can do a code amendment. If you're going to check, if you're going to recheck, or if you're going to change anything in your program, you can do it with the help of iterative testing. And then finally, testing. The most important thing again. You are the user of iPhone, you are the user of Samsung mobile phones. How do you think? Are these phones amazing or not?
Yeah, it is.
They are amazing. How do you think like that? My question is, because you can say, sir, their programming is amazing, their options are very easy, and it looks very beautiful. They have a sleek design. Their operating system is iOS or Android. They are easy to update, isn't it?
Yeah.
So my question is that, what do you think? Are they going to test these mobile phones before launching in the market?
Yes.
So do you know iPhone, Samsung, and other companies given the mobile phones to their employees for 6 months, for 3 months, for testing their phones? So the employees are going to use them before the launching in the market. They use it for the 3 months, 4 months time, and they are going to check everything in the phone, using them in harsh weather condition. And then they're going to make a report on them that phones are perfectly fine. You know that. So after this testing, the mobile phones will be launched in the market for the customers. So the testing is the most important part of the whole programming. Are you getting it or not?
Yes.
So the completed program or a set of program is run many times with the different sets of test data. Yes, there is a word called test data. I think you're familiar with this word, test data, right? So in the test data, how many types? Normal data we have, abnormal data. Do you know these things?
No, sir.
Okay. Extreme data and boundary data. So we are going to just check our program with the help of these types of data all the time. Right? So after the testing of our program, now the program is ready to launch in the market. So take out your notebook, write down these points in your notebook, and then we will proceed. So you need to write down about design phase, coding and testing, and testing. Okay?
Yeah.
Please tell me.
So there's 4 stages. There's analysis, design, coding, and testing.
Perfect.
In analysis, there's 2 stages, which is decomposition and
Okay, fine. So now we are going to study about the computer systems, like how we are going to manage a computer system. So we know that computer system is made up of a software, data, hardware, communications, and of course, human beings, people. And every computer system can be divided into a set of subsystems. So I teach you already about subsystems. So I'm just moving here on the topic of subsystems. So look, we are going to break down our problem into a set of subsystems. So again, the same topic is here, decomposition. That is the reason I teach you the same thing before. So this is for subsystem. Further, you are going to divide your subsystem into further subsystems. So the same thing I teach you in decompositions, and the same thing I'm teaching you here as a subsystems. Can you tell me another name of this subsystem is? The another name is top-down design.
top-down design.
Right? So top-down design is a decomposition of a computer system into a set of subsystems, then breaking each subsystem down into a smaller subsystem. So this is a subsystem, again this is a subsystem, again this is a subsystem. So breaking down the system again and again into a subsystems. This is an effective way of designing a computer system to provide a solution to a problem. Right? And this breaking down of a problem into a smaller subsystem is called stepwise refinement. Is that okay?
Yes.
Breaking down a problem into a subsystem, then again breaking that subsystem into a again subsystem, and so on. This breaking down of a problem into a smaller problem, more and more smaller problems, becomes stepwise refinement. Right?
Yes.
Okay, so I teach you about the top-down design, the subsystems, the decomposition, right? And subroutines also. So these all things are come under the same thing, right? And another name I forget is structure diagram. This is also called a structure diagram. So if in your exam you will get a question, you need to write down the answer the same for top-down design or structure diagram for decomposition, and for subsystems. Right?
Okay.
Great. Now we are going to decompose our problem into 4 stages.